isn't it really complicated to build web apps? What if it was just way simpler to build an awesome app that was fast, that was really responsive, that stored all the data people care about, was easier for you to develop, faster, simpler, less ops maintenance stuff? The data ownership stuff just falls out as a consequence. Could we leverage the power of databases and the power of the local first architecture to cut through a lot of the complexity of building modern web apps and make it simpler?
Welcome to the Local First FM podcast. I'm your host, Johannes Schickling, and I'm a web developer, a startup founder, and love the craft of software engineering. For the past few years, I've been on a journey to build a modern, high-quality music app using web technologies. And in doing so, I've been falling down the rabbit hole of local first software. This podcast is your invitation to join me on that journey. In this episode, I'm speaking to Geoffrey Litt, who's currently a researcher at Ink & Switch. Geoffrey has worked on many interesting research projects such as Riffle, Cambria, and Embark. In our conversation today, we're talking about the ideas and goals that motivated Riffle, which include expressing an app as a query, fast synchronous reactivity, and unifying UI state and app data in a single system. Before getting started, also a big thank you to Expo and Crab Nebula for supporting this podcast. And now, my interview with Geoffrey. Welcome, Geoffrey, to the show. So excited to have you.
Thanks, it's great to be here.
I mean, you and I have been working together now for a few years, but let's rewind time a little bit and maybe start where you and I have first crossed paths. This was, I think, the end of 2020, and you've been just wrapping up your first project at Ink & Switch, which was about Cambria. So would you mind motivating what the project was about?
Yeah, absolutely. So I'm a researcher that works on a topic called Malleable software, where the idea is, can we let everybody customize their software tools to meet their own personal needs rather than everybody changing the way they work to match standardized software tools that other people develop, right? It turns out one of the core problems in this space is wrangling data schemas. So imagine, you're using your favorite to-do app, I'm using my favorite to-do app, and we decide we want to work on a project together. What are the options? We either have to pick the same to-do app, or if we want to each keep using our own favorite to-do app, those apps need to have some way of talking to one another and sharing a data representation, right? And it turns out that this is a pretty gnarly problem because those data representations our two apps want to use might be different in subtle ways. Perhaps your app has subtasks and mine doesn't, or something like that. And so the goal of Cambria was to explore this problem and try to figure out, could we find a way to enable collaboration across diverse tools while also not requiring all of our tools to share exactly the same data schema and all agree on everything? And it turns out that this is actually sort of a pervasive problem across local first software in a bunch of different contexts. This problem pops up in many shapes and forms. Even the simple case of like having a centralized application written by one developer in a local first context, schema migrations and upgrades often become a lot harder than they are in sort of a server-based environment. So the Cambria project, again, was about sort of first just recognizing that this problem exists everywhere and that it's really holds back progress in terms of interoperability and schema management in local first apps. And then we sort of prototyped a solution to it, which was, you can think of it sort of as a live data translation system, where as different tools are working on shared data, there's a layer underneath the individual tools that helps translate data formats between all the various tools in such a way that each app can feel like it's just working with the data representation it wants, but actually under the hood, where we have some sort of translation layer that's sort of serving as the glue that lets different versions of the same app collaborate, or lets even different apps entirely collaborate with one another.
Yeah, I think that's a brilliant motivation. I remember having read the essay the first time, was super well illustrated and super well motivated. It sort of almost provoked me into re-implementing a version of Cambria myself back then. This is how much it kind of spoke to me, since I remember the first version of Cambria was then sort of like a DSL expressed in YAML. I am more someone who's working mostly in TypeScript. So I remember re-implementing a small version in TypeScript. So yeah, I love that problem statement. And so I think it's also interesting how it fits into this broader umbrella of Malleable software. And turns out, looking back over the last few years, this is not the only project you've done in the realm of malleable software. So, which other problem spaces have you run into while pursuing this goal of malleable software?
Yeah, I think it's a fascinating space. The way I got into it was originally was actually I was working at a startup building normal SaaS software. And, we were doing what SaaS companies do, which is that you have 30 people in a room somewhere designing interfaces that thousands and thousands of people, thousands of miles away are supposed to use, right? We were in our case designing education software for schools. And I just remember talking to all these teachers and principals and all these different schools, and they had very specific requests often, as customers do. And of course, in SaaS, typically the answer is no. You have to be disciplined and say, I can't change the wording of that button just for you. I'm not going to add a setting for that. But I started to find this very frustrating and wanted to explore what would it feel like if software worked differently. And I think there's an interesting connection to local first because I remember coming across the original Link and Switch essay about local first when I was starting to think about this stuff. And I think they said briefly in the essay something about how it seems like an intriguing foundation if you have data locally and maybe even code locally available that gives you a little bit more access and control over your software than if you have a cloud SaaS architecture. And that sentence really sort of sparked a bunch of thoughts in my brain that have led, I think a lot of my work, the way I see it is sort of at the intersection of how do we use the local first architecture to enable more malleable software for end users is a theme that I care a lot about. So Cambria was definitely one project in that line. I've worked on a couple other projects in this space. One project I worked on early in my grad school research career was a little browser extension called Wildcard. And the idea was, what if you could access the data underneath any web page in a spreadsheet? But it's not only a read-only spreadsheet, you could even write to the spreadsheet and mod it yourself. So a very accessible way for normal people to make their own browser extensions without programming.
I love that. And I think as a fun fact, this might have actually been the very first point where we've been put in touch, because at that time I was also working on my little own Chrome extension, which was also kind of in a direction of malleable software. This was before I was even aware of the term and like that broader field. I was just motivated by my own frustration that the websites didn't quite work the way how I intended. So it feels like we've been on similar paths there. And what you've been building with Wildcard was quite a step ahead of what I've been coming up with at that point. But yeah, that
Well,
was.
yeah, I remember one thing about that I think maybe is a preview of the way we've collaborated since then is that mine was a more speculative prototype of a interface design, but it wasn't particularly solidly implemented. And I remember you had this really fancy developer experience around customizing your extensions and stuff that I got inspired by. And so I think there's a fun interplay there we can get into later about kind of more speculative research versus engineering more solid versions of the idea.
Yeah. So you've been working on Wildcard. Which other results did come out of your overall research in that field?
Yeah, so throughout the years, I've had the chance to work on a bunch of projects with mostly with really awesome collaborators. One of the more recent projects, we actually worked on together, was the last project I worked on in grad school, which is called Riffle, and that was a project that you and I worked on together with Nicholas Schiefer and Daniel Jackson, my PhD advisor at MIT. And sort of I guess the origin story of Riffle is that Nicholas and I were having a bunch of conversations that revolved around sort of this idea of having a personal data store. So, one way I think about cloud versus local first is that in local first software, one of the ideals is that you own your data. And these valuable thoughts that I'm having and artifacts that I'm producing in the digital world, they should feel like mine, just like a notebook I can carry around and, have with me forever, right? And there's this question of, great, if you own your data, sure, you get longevity and control, but what about this ability to take arbitrary tools that I want to use and connect them to that personal data? This is something that's often really hard in SaaS because the data is locked away, and maybe there's the APIs you want, and maybe there's not, and maybe there's the partnership you want between the two tools you use, but maybe not. And we were talking about, how would it feel if you had a local first data store with all your stuff in it, and you could connect whatever app or tool you wanted to that existing data store that has all your stuff, right? What shape would that data store take? How would it work? How would you develop against it? And one hypothesis we wanted to explore, particularly because of Nicholas's background, which is in databases, we wanted to sort of ask this question of what if you had a really powerful database that was designed for this purpose? Maybe it could be based on relational databases, and maybe the experience of building an app on that foundation could end up feeling really different from traditional software development in a bunch of ways. So that's kind of how we got into the Riffle work.
That's incredible. And if I remember correctly, this was not the first time that Nicholas was also working on this field. He didn't just work on databases, but I think he was at Apple previously and was implementing similar systems, I think related to iCloud and how syncing works there. So yeah, I mean, those are some pretty big ideal that is not a very common thing in the apps that I'm using. It's if God forbid something like Notion would shut down, like what would even happen to my data? So I would love to see that flip of like everything that I'm creatively producing is by default mine, and turn around the relationship. But it's not even that you wanted to, if from a idealistic perspective, push for that. But I think you took a step back and say, okay, what is even the technical foundation for that? What would a prototype of that look like? How did the project get off the ground?
Yeah, so one way that I think about this is exactly the way you put it about the difference between ideology and technical foundations. I think that data ownership, one of the reasons we don't have it is because it's hard to build apps that way. It's not, I think there are often companies that don't really have a strong desire to build a SaaS data moat. It just is kind of the default that is promoted by the way we naturally build stuff. And because it's so hard to build apps with data ownership, we don't get that many of them. And one of the, I think, most interesting potentials of local first as an area that I don't think has been fully realized yet is what if we could make it easier to build apps this way rather than harder, right? I think a lot of people in this space see that potential for this radical simplification of how we build stuff. I think Peter, who was on the show, has sort of inspired a lot of my thinking on that. I think Martin Klutman, who was one of the co-authors of the local first piece, has given talks about how you sort of have this many-layered cloud architecture, and in theory, it could be so much simpler if you didn't have to deal with all that stuff. But again, in practice, I think we're still getting there as a community, and the reality is we're still maybe in the zone where it's harder today. And so, one of the ways that I thought about the Riffle project, and Nicholas and I and Daniel thought about it, was what if the pitch to an app developer for something like Riffle didn't start from ideology. It didn't start from you care about giving your users their data and providing interoperability, blah, blah, blah. The reality is, for many people, these are not the most pressing concerns. What if we started instead from, hey, isn't it really complicated to build web apps? What if it was just way simpler to build an awesome app that was fast, that was really responsive, that stored all the data people care about, was easier for you to develop, faster, simpler, less ops maintenance stuff? The data ownership stuff just falls out as a consequence, right? So a lot of our Riffle work was focused on, could we leverage the power of databases and the power of the local first architecture to cut through a lot of the complexity of building modern web apps and make it simpler? And in service of that mission, a few of our starting principles were, can you think of an application as one giant database query? What I mean by that is, instead of writing a ton of normal code that produces your UI, could you somehow push a lot of the work into a optimized database that does a lot of heavy lifting and let it produce UI states for you? Another thing that couples really well with that is fast synchronous reactivity. So we had this idea that the data is already there on your device. Throw away all the async crap that comes with web apps typically, React suspends network requests, and work with the data that's already there and simplify just talking to it and querying it. And the last thing, our third principle, was, can we take all these different kinds of state that typically end up in different systems and throw them in one? So your React UI state and your persistent local device local state and your synchronized multi-user state, can you just store them in one system? And then, we like to think of it as maybe there's some setting checkboxes on each bit of state that tell you, should you share it or whatever, but just have one system that's capable of subsuming all those roles. And our hypothesis was that if you pulled all this off, it could feel really awesome to build apps And you would get both better apps for end users because they're fast and they work offline and they have all the local first goodness, but also you could get a better developer experience because you've removed a lot of the layers of traditional web apps.
So this was a lot. And spoiler alert, that hypothesis that you've motivated, at least in my very case, paid off big time. So the developer experience for me as a developer is better. I hope that the end user experience will be better, partially also because I care a lot about performance and making things nice. But to kind of crack the chicken egg problem of like, how do you even build better apps with this in the first place? What really was the motivation and the catalyst for me was not all the ideals of local first. Sure, I would love them, but that would not really make the difference for me. Like start to work on an app and build in one architecture or another. But the more things I didn't have to do in the first place, the better. The more I could really focus on working on the app. And just to simplify the entire stack, your motivation to say like, hey, actually, why do you even need a server? Why do you need a backend for the thing? Ultimately, the app is working on your client. How about that being the starting point? That really spoke to me. And this drew me in as an app developer and where I believed in that mission. So yeah, I couldn't agree more. And I would love to dig more into the various principles that you've mentioned, since I think there's quite a bit of like interesting thinking behind each of those. If I recap it correctly, I think it was simplifying the inner workings of an app into basically database queries, aka like complex SQL queries or however else you want to express it. Then the synchronous graph of typically how React works, etc., coupling that directly together. And the third part, oh, you got to remind me about the third part again. But let's go through them like one by one again and with a bit more detail.
Absolutely. So, the first principle I talked about is thinking of an application as a database query, right? And actually, to throw a little more detail in there, it's not one database query, it's actually a graph of database queries with dependencies. Now, that starts to sound kind of fancy, but I think we all understand this model from using spreadsheets. The metaphor I think to think about is, can you make coding a rich, complex application as simple as using a spreadsheet? Spreadsheets, dependency tracking of formulas and automatic dependency propagation is the bread and butter of spreadsheets. It's one of the key features that makes them useful, right? When you're using a spreadsheet and you update a cell, the contract that Excel gives you is typically instantly, or at least very quickly, unless you're in a huge spreadsheet, everything will be up to date. You're never worried about staleness. You're never thinking about caching. That complexity of dependency propagation is pushed down into the system, right? And I would note, I think this is a lesson that we've definitely learned in UI development. You could definitely say that reactive UI frameworks like React.js give you something like this guarantee, right? You declare the UI you want, and state and DOM are synced automatically. The problem that I see is that often in our web stacks, this reactivity is partial to one part of the stack. So in a common web application, your React UI, what it's faithfully representing is not all the state in your system. It's some view you currently have in this tab of some larger state that is, maybe primarily on a server. And that introduces a lot of complexity because all of a sudden you have your nice declarative spreadsheety React thing, but then you have at some point in your stack, you're going to start hitting data fetching, you're going to start hitting sending writes back up to the server. And that's just an enormous source of mental model overhead, I think. On the flip side, there have been some interesting research projects which come out from the other side. And people, for example, have literally tried to make UIs in things like Google Sheets. There's a really neat project by Ted Benson and collaborators called Quilt that literally they use Google Sheets to power your entire backend and all your UI templating, and essentially. The problem there is normal spreadsheets aren't really powerful enough to do that, and they're not really architected the right way. So one way to think about what we were trying to do in Riffle is, can you take the beautifully simple model of just declarative dependency propagation and apply that to your entire data stack? So your mental model as a developer should be, I just have all the data locally. I'm just writing a spreadsheet that turns it into a UI, and the system will take care of the rest. Full stack reactivity. That's sort of principle number one.
that makes total sense, and I think you've touched on also like the third principle, which I remember now, is like the unifying the UI state and sort of the other app data. And if you really think about it, where do you even draw the line between something being UI state, something being app data? There's sort of like an arbitrary line. Maybe I think de facto in most today's web apps is the app data is like what you fetch over something like React query as your website boots up, or you have it pre-hydrated, and the app state is more of like the in-memory stuff that if you reload the page, is poof, it's gone. But ideally, most of the things should really be treated in a very similar way. When I'm thinking of a native Mac app, for example, like Finder, if I close a window and I come back, the same items are still selected. I'm still like roughly in the same position with the folders that I've selected and the hierarchy. And most web apps, I would actually suffer from that. They have like basically they're suffering from dementia when you insert something in a form, and maybe you really need to look up every value, and maybe the form expires, you reload, everything is gone. That's I think everyone has like those terrible user experiences. And so treating everything as the same data, I think is a kind of a bold, but in my experience, like the right step. And then if you can, therefore, as a conclusion, kind of like have all the data that you need to work with, have that locally. It simplifies everything to such a degree that it's really liberating. So that's sort of the third, the principle. And I think that's a really bold one, that is, I think, the most provocative compared to the traditional way of building web apps today.
Yeah, exactly. Just like you said, I think it can be a disrespectful user experience to lose people's valuable input. Even something like scroll position or, like you said, intermediate form state can be something that I put a lot of work into and I don't want to necessarily lose, right? Now, I think the deeper reason we end up with software like this isn't that people don't care. It's really that we've made it hard to do. So again, it's this technical defaults ruling the user experience situation that we talked about, where, imagine you're a product manager and you get a request to please persist this user input or share this user input across users. And the engineer says, oh man, that was previously React component state. And now I need to like re-architect where that data is stored and plummet through a bunch of places and add a database column for it, blah, blah, blah. It's all this work. And the goal of having a unified system for all your state is not that all states should be treated the same. Definitely some state, should be user local, device local, and so on. Some state you want to reset on new sessions by default. So you can think of that as ephemeral. But if you store it all in one system and manage it all in one system, the goal is that it becomes much easier to move between these states, right? One example I love is that someone who's working on a collaborative app told me the state of whether a context menu is open in a spatial canvas app. They actually realized they needed it to be shared because when I open a context menu, my cursor is moving around. If you can't see the context menu I'm using, you don't really know what I'm doing. And so I think that's a perfect example of blurring these boundaries where something that seems like clearly a quote unquote local component state in a traditional framing might actually need to be collaboratively synced or maybe even persisted. So that's what I see as the goal of having this unified state management system. And in the Riffle work, that's basically the maximalist view we took is no React state, right? Every single bit of state in the system flows through this one database, and your UI is just derived from that one place. And you can always reason about essentially the pixels on the screen are a function of the database. That's it, nothing else. And we found a lot of neat qualities that design led to, along with a bunch of interesting challenges.
And I have to say, I was not on board with that when we got started. I was so attached to like everything is in React, and you have like things inside of React components, etc. And I remember Nicholas, he was like on the opposite side there, and so like no, 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 like React should do as little as possible and like have your state outside. And that didn't click quite back then for me. But step by step, I came around to it, and I'm now also like on a maximalist side of like most stage should live outside of React. And for example, for Overtone, there's a very simple case where you, for example, for the app for the playback of your player, like you want your playback to happen. You want to hear something. Maybe you capture the time code of the current playback progress, and even if the app is not open, you want to still hear things. If you reload the app, you might just still want to recover at the correct playback position. So all of that state is kind of headless. So the state still lives on, and therefore wouldn't quite make sense to have that be part of React use state. Sure, you could say you have like a headless React component, but that's already feels a bit backwards at that point. So once I've started embracing that, it was hugely liberating. And now I can start to reason about my state outside of the context of React components and outside of React view state. So that took me a bit to get around to it, but I'm fully on board with that principle now as well.
And I'll mention. I don't think we're not the only ones who've thought of this, right? I think the idea of having a reactive state graph separate from your UI tree is something that other web dev libraries have explored. MobX, Recoil, arguably even something like Redux, I think, shows some of the power of having this sort of centralized outside of your UI tree state management. There's definitely, I think, some broad recognition that this can be a powerful pattern for some of the reasons you mentioned. But I'll also mention, like, there are some challenges, right? And I mean, you've encountered some of these. I'd be curious to hear your take. Some of them that I think immediately come to mind for people are, one, performance is always an easy one. Like, typically we expect button hovers and selection changes to happen at 60, 120 hertz. And we don't expect things like loading thousands of rows of data from our core data store to necessarily happen at the same speed. And so that mismatch can be an interesting thing to manage. Our motto, Nicholas's motto to some extent, is just make everything fast. If everything goes at 120 FPS, then you don't have a problem, right? Easier said than done, but I think a fun goal to shoot for.
So far, mostly what we've been talking about is conceptually a simplification and getting on board with that different way of thinking about your app on a conceptual basis. And I think for me, it took a little bit of time to ease into that and then be confronted with the new challenges that are raising. We'll go into the challenges in a second, since we've encountered quite a few. But I think we didn't quite touch too much on the second principle you've motivated before, which is the synchronous reactivity, and like that should be as fast as possible. We'll go into the performance challenges there in a bit. But when you've said synchronous reactivity as opposed to asynchronous reactivity, why is this a principle? Like, what is so important? Can you motivate the problem and the status quo and how Riffle's challenging that?
Yeah, absolutely. This is a really important principle to me. I think when we build web apps that have a server, we assume a lot of asynchrony at many points. So obviously going on the network to a server is a point of asynchrony. Even often loading data from, like a local disk, right? We think of as an asynchronous operation. And because of that, UI development typically has a lot of reasoning about asynchrony, which is a really hard thing to do as a programmer. For example, you might have a UI where there are loading states, and everywhere throughout your app, you need to think about, am I still loading or do I have the data? And maybe you have a UI that's composed of different sections, and some of them might be loaded already and others aren't. You might have intermediate states to reason about, like after I select something in a sidebar, there's some time where the main other pane of the app hasn't reacted to that yet. So it might still be showing the old thing that was there before I selected the new thing, or it might be showing a loading state while I'm loading the data. And my experience, at least personally, has been that we kind of accept this as just the way it is in UI development, but it's terrible. It's a lot of overhead to reason about. There are many, many more states your system can be in when you have asynchrony, right? The vision for synchronous reactivity is, let's make it, again, feel more like a spreadsheet. So the way I want my UI to feel is that when I select something, on the next tick, on the next frame, every pixel in the UI has fully updated to reflect that new user input. And that's obviously good for users because they didn't have to wait. developers because you don't have to reason about the intermediate states. You can sort of think transactionally, where the state of the world changes, and transactionally, we update a bunch of derived views and queries of that state, which end up in the pixels of the UI. And there was never any intermediate state exposed. And it's it's sort of a subtle point to get across, but my experience has been that when you work in a system like this, it just cuts a lot of complexity.
Yeah, it's not just a simplification in terms of architecture that we collapse the stack from backend and API, etc., in all into the client, but that's like one giant dimension of complexity. But there's a second, much less talked about vector of complexity, which is like how are things related to each other? Can they be synchronously related, or do they have to be asynchronously related? And this is where I think we're getting into the area of distributed systems. I'm sure we'll talk a lot more in future episodes about broader distributed systems where they're really needed, where you have a device, you're in the US, I'm in Europe, and so we are distributed. However, if we are starting to treat a local React app that's running in single thread, and we're coordinating the various React use states things with React use effect, we've kind of accidentally created a distributed system that's really hard to tame, and where there can be many unintended bugs, and it just starts becoming a lot more complex to think about. So this is the other part where I think where Riffle again liberates so much and simplifies and frees us of the accidental distributed systems problem that we have in most modern web apps.
Yeah, I think two principles that I think about. One is don't make something a distributed system if it really doesn't have to be. And two is if it has to be, someone smarter than me should do the distributed systems part, right? Really, we should be providing abstractions that allow us to not think about the hard parts most of the time. Even, I'm not a CRDT expert, but I know quite a bit about CRDTs and have done some work on developing CRDTs. But and so I probably know more about CRDTs than a lot of app devs, but I don't want to think about distributed systems when I'm building some product feature, right? And I think that is clearly one of the core challenges in the local first space that I think a number of projects and companies are trying to address, which is what are the good abstractions you can expose to app developers that allow them to reason about tricky distributed systems problems in a straightforward way without needing to turn on your sort of distributed systems brain as much.
Yeah, exactly. And I think the being confronted with distributed systems problems there is much more common than most app devs think. So most of the time when in React you use effect, that hook, to somehow tame your local state, then you already have a distributed systems problem. Things like React suspends and so on. That's kind of like a solution to address partially the distributed systems nature that you have in React. So I remember having, when React suspends and all of those primitives came out, I was kind of wondering, how does that fit into our Riffle world here? Would Riffle at some point support React suspends? And then at some point it clicked for me. No, that's like addressing a problem that we've already ruled out before, and we don't even have to think about that complexity at all. And this is like an entirely different approach to addressing the problems that React suspends, etc., is addressing I would say, in a much simpler overall picture.
Yeah, I think maybe to avoid overclaiming here, I'll say there are some trade-offs, right? I think often these approaches that involve concurrency are they're optimizing for either the reality of something like a slow network request or for sort of worst case performance, making sure that you keep some things running fast even if other things are slow. And I think there's a different approach you can think about, which is, in a nutshell, just make everything fast. And as long as everything's fast, it'll be simple. If things get slow, you might end up with a worse experience than you might have in a system that that is designed around concurrency. For example, maybe in a riffle style approach, if you're trying to synchronously paint frames and something is slow, you might just end up with a ton of dropped frames and sort of a frozen UI. Whereas in a system designed to account for that with better concurrency support, you might have a loading spinner and some things remain responsive. And so I think part of the challenge is figuring out how to balance those two approaches. And as we've seen in our work, I think sometimes you do need to account for the reality of sometimes you have to make a network request because you're talking to an external service or something, and you do need ways to model concurrency. It's just that I think we don't need to, I guess, throw the baby out with the bathwater. Like, not everything needs to be concurrent, and some things can be fast. I think I don't have much game dev experience, but my understanding is that a lot of video games, essentially, they paint frames and they make sure every frame is fast, and they don't drop frames because they make sure the frames are fast, right? And I wonder how much of that ethos we can apply to general UI development as well.
So we've been referring to this thing Riffle now throughout this conversation, and clearly you and I are well aware of what Riffle is, and you've motivated what Riffle is supposed to be through the principles and sort of what you were hoping to achieve with it in theory. But in reality, what is Riffle?
Riffle was a research project. And so our primary goal was to try to get some of these ideas into people's heads. But we did need a way to test them out and see, is this even possible? Is this really a good idea? And to do that, we built a simple prototype, reusing existing parts as much as possible. Namely, we built on React.js as a view templating layer, and we built on SQLite, which is a popular relational database that can be embedded on devices and in the browser through WASM. And what Riffle is technically is a layer that sits between React and SQLite. And what it does is it lets you specify a bunch of SQL queries that turn a SQLite database into a React UI. And it gives you some hooks in your React UI to do things like query data in a component or make writes to your database. And you can think of it sort of as a state management framework built on top of SQLite for React that tries to realize some of these ideals we just talked about in a concrete way, right? Now, again, this was just sort of a prototype to explore the ideas. And one challenge we faced early on was, how do we really test out if this works in the kinds of contexts we care about, which are complex data intensive apps with pretty large amounts of data, relatively speaking, and interesting schemas and strict performance requirements. To do apps are kind of boring and don't really address any of those. And that's actually how we ended up collaborating with you on this. So maybe do you want to tell the audience a bit about how you got involved?
Yeah, totally. We've been in touch since you worked on Cambria, and I think we've been catching up once in a while. And then at some point, I learned about you thinking about this broader space and rethinking state management. With my background of Prisma, I'm obviously no stranger to thinking about state management. I've been thinking about how to make it simpler, typically more in a backend context. And for me, this was really the interesting foundation that you said, like, hey, why do you even want the backend? You want to build an app. You didn't quite say it like this, but this is the way how I how I had sort of picked it up and framed it in my head. And that was a really stimulating idea for me to say, like, actually, yeah, let's bring the database into the client. I was using a lot of MobX and Redux and those sort of things in the past, and they worked. They made me productive, but they didn't have the properties that you mentioned before. That state wasn't persistent. It fundamentally treated state and data differently. I would fetch my data from a backend. It was a very interesting idea for me to have the data all there locally. So, and I was thinking about building my own music app for quite a while, and Riffle seemed like the perfect catalyst for me to really take a stab at it. And the only way how I could really make progress on such a big effort, mostly by myself, was to cut scope as much as possible. And that was a very simple math to say, like, hey, we can cut the scope from the backend categorically, and I can focus all of my energy and time on building the best client possible. And a music client is nobody talks about, oh, that's the best music backend. People want the best music app, and that has led me to become the first design customer, the first design partner for Riffle, and that made a brilliant combination, I think.
Yeah, I think one alignment in values that has really helped here is that you're trying to build a music app for power users, right? And I think power users often care about things like data density, latency. It's funny when you look at apps like Spotify, for example, and we've talked about this many times over the course of this collaboration. Spotify, their desktop app is quite slow often and also quite network reliant to a surprising degree. Many page transitions that we've encountered, even for data that is already locally cached, for some reason has a lot of network access going on, and you often get multi-second loading screens. And I think for serious music people like DJs, some of your target audience for Overtone, I think of it a bit the same way that serious email people like apps like Superhuman that respect their time and make them really fast at email. A serious music fan wants an app that feels good and not some, loading screen filled consumer feeling app, right? And I think that was really aligned with some of the goals that we wanted to hit with the Riffle approach is basically, can you just throw all the music metadata in a SQLite database, use relational queries, which are really good fit for things like joining together albums and artists and tracks, things like that, and power the kind of power user experience that you wanted to build.
Exactly. And I think this was literally also like the starting point for our first prototypes to do a data model and kind of employing similar ideas that you use in backend development, where you first lay out your different tables. In this case, I didn't actually create a user table. I still don't have a user table since the app just runs locally. But I did create a tracks table, and an albums table, and a playlist table. And we threw that together, and within the shortest period of time, we had a fully functional, very crude music app. And step by step, yeah, we I think we've been looking for reasons why it doesn't work, and we never found that reason. And then the months passed, and the collaboration now lasted, I think, for almost like 2 years. And you've confirmed the hypothesis that you had with your PhD thesis at MIT for Riffle, and this made for a brilliant partnership.
Yeah, I think, one of our goals with working with you was that, first of all, yes, like you said, if it went well, which I think it has gone better than we expected, then it's more valuable confirmation, right? That like a real serious app works with this than like a to do MVC demo. So I think that was one thing. But also, the primary goal was not that. The primary goal was to uncover what the real challenges are of building real software in this model. And maybe you could talk a bit about, throughout the project, you've been a very useful critic and sort of have pointed out a lot of the problems and challenges that come from working in this way. And I'm curious what your take has been on what the biggest problems we've had to solve have been.
Totally. So I as a person, I like pioneering things. So I have probably a higher risk appetite, and I can deal with like a couple of more paper cuts temporarily than someone else who is just looking for the best well trodden path. So this made me a viable partner here, as opposed to someone who only touches the technology that is already well proven over the years. And so I was rather looking for an advances on a in a broader scale, like on an architectural level, and just something that in the long run can help me reduce and avoid complexity as much as possible, even though temporarily possibly dealing with enduring a few more paper cuts here and there. And given that I am both comfortable in the shoes of an app builder as well as in the shoes of a tools builder, I think I was uniquely positioned to switch between those two modes to unblock me, etc., and to have enough imagination to understand, oh, this is not a categorical flaw in the way how things are right now. We can fix that through better tooling or refactoring of the API. This, I think it was kind of in waves, where there was some waves of immense productivity and things been working much better than expected. And at times we've hit some walls of doubting, is this ever going to work? Are those principles, the ones that we've picked, are those the right ones? Is it a good idea to keep our entire state graph synchronous? Can we make it fast enough? So we've been hitting those challenges, and the ones that are most memorable to me was really around performance. I can motivate it from my perspective. I've set it for myself as a challenge. I want to build a music app that's fundamentally built with web technology that should still feel as fast as a native app. So that means if you're now looking at a 60 hertz display or 120 hertz display, if you scroll, if you interact with the app in some way, it should work without frame drops. And given that all state management, everything that changes on your screen is fundamentally a result, an implication of state change, and that this happens smoothly, it needs to happen in 120 hertz. So that basically gives you per frame, yeah, less than 4 milliseconds to do everything: state change, render, react, etc. So performance was always top of mind, and I think that where we've been going back and forth, oh, is it ever going to work? Oh yes, we can make it work. And that has kept us busy for quite a while. And I think we can go more into depth what that meant. But that's the top challenge that comes to mind. Besides a few like paper cuts and also figuring out like how do we the starting point, even though this is a local first podcast, Riffle up to this point was mostly local only. And just in a later point, we're introducing the collaboration aspect to make it truly local first. But yeah, I think performance has been the major challenge that we've been facing.
The way I think about performance in this stack is that the role of the database is to make things fast. What a database does is you give it nice declarative queries and it figures out how to make them fast because some smart people worked very hard and you didn't have to do that work, right? And I think a lot of the challenges we've hit basically boil down to we don't quite have the right database for this use case or shape yet. A lot of UI stuff, I think, boils down to the problem of incremental computation. Incremental computation is a pretty broad, computer science term that basically means I have a function and the input changes a little bit. Can we figure out how the output changed without starting over from scratch on the fresh input, right? And this is a problem that people have approached from a number of sides. The sort of programming languages community has approached this problem. Incremental computation is a keyword that can highlight a lot of the work there. But the databases community has also thought a lot about this problem. They often call it incremental view maintenance. An example might be I have a big join on thousands of rows and I add one row to the table. How does the result change, right? And I think a lot of the reasons we've had performance challenges is that our technical stack has mostly been based on SQLite, which is a database that is sort of built for UI but is not incremental. We did some explorations with a database called SKDB, which is actually a SQL database designed to be incremental. And that yielded some pretty interesting and promising results. We actually published a paper at the WIST conference, which talked about some of our positive results from working with that technology. I think ultimately you ended up deciding to stick with SQLite for the production overtone app because you wanted sort of a more, mature database to work with as your foundation. But the way I see the problem is really that we sort of need the right database that has the right primitives to make UI development of this sort fast. And maybe the perfect database for that doesn't quite exist yet. I think that's the missing piece, and the ultimate, decade ahead, if this really panned out, version of this stack, I think would include that database.
Yeah, totally. And I think it's a matter of like now it's the early 2024. Who knows? Maybe next year the world has already moved closer in the direction that is a good foundation for something like Riffle. The audience shouldn't have the takeaway of like SQLite is slow. Quite the opposite. I think this was the insight that SQLite is incredibly fast and remarkably capable was the foundation to embark on this project in the first place. And Nicholas has been, through his prior work at Apple, done a lot of work related to SQLite and I think related to FoundationDB. And that was one of the key insights that we say, like, actually, SQLite is so fast and now can be embedded into web applications through WASM that it can be a replacement technology for something like MobX and Redux. So before WASM, etc., and all of the optimizations that have gone into that, this wouldn't have been possible. But now that's possible. This allowed or a better foundation for to deal with complexity. Since if you build something with mobx, etc., you still need to wrangle all of your JavaScript objects by yourself. Like if you want to have like a filter or a map or a group by, you got to implement all of that yourself. And the app user experience that I want to enable with Overtone is this will be very common. Think about it like in Notion when you have the tables feature and you configure a few sorts, you configure some group bys, you have different views. Those are all things that get very boilerplatey to implement with JavaScript. And those are all things databases are super good at. And this is what got me over the fence to say, like, actually, let's embrace what a database is good at and build a bit of like the React nice to have things around it. And I think the core of what Riffle is really like that combination of a underlying SQLite database and put a reactivity system on top of it. And reactivity system in that regard of like how React components compose, and if one thing changes, then the other thing updates to the minimal degree. That's what Riffle is doing, and a very simple idea with many implications and remarkably powerful.
Yeah, I think you're right, and it extends beyond performance too. I think when you think about the requirements of what a UI needs, I think that when you remove all the layers that typically sit between a backend relational database and a UI, those layers were there for a reason. They were solving some problem, and you end up needing to find ways to solve those problems. So often UIs need tree-shaped data to hydrate a tree of a UI, right? Often front-end developers don't already know SQL, and often actually SQL we found can be a mediocre language for certain parts of UI development. It often just feels a little bit too low level or something. Obviously, having worked on Prisma, you I think have experience with some of those problems in the backend context, but I think some of them become even more apparent in a front end context. Some of the, I don't want to necessarily say the ORM word because I think that's a touchy topic, but I think some of the roles of associating different kinds of models with each other and things like that, there's sort of sometimes feels like there's a need for that kind of layer, right? I think in our technical prototype stack, what we ended up doing was stuffing a GraphQL layer in there between SQLite and the UI, because you're a GraphQL expert, and that helped alleviate some of these problems. But again, I think we see that more as a shim, right? Like sort of a layer that shouldn't need to be there, but it's there because the database didn't quite have the right shape. And I think some of that reflects that maybe no one has ever designed a database specifically for this role of being embedded so closely to a user interface.
Yeah, totally. I mean, I think about it this way. We want to take one or two steps forward, but in order to do that, we also had to take a step backwards. And the step forward that we took is that we get the power of a database, that we get all of those semantics that a database give us, whether it's group by and sorting and nested selects, etc. All of those great things that would really freeze up our work and make some things that we would need to imperatively implement in JavaScript makes that declarative. However, the steps that we're taking back is that SQLite is quite limited. It doesn't have many data types. It doesn't even have a Boolean type, etc. So you need to do a lot of translation between the way how SQLite understands the world and how someone who's like a more sophisticated TypeScript developer as me, I'm used to having all of my fancy TypeScript types and to create a good translation layer between that embedded SQLite database and what I want in my JavaScript. Now we got to reinvest in that. And so you've mentioned GraphQL. That was sort of a technology that I was quite familiar with from prior work. And I think that's sort of a temporary usage until we teach SQLite some of the tricks that TypeScript already knows, and until we create a better mapping in between that. But that's certainly been another, for me, less of a challenge, but it still requires quite a bit of work to make SQLite feel kind of native in a TypeScript setting.
Some people, I think, believe that one of the sort of original sins of computing, so to speak, is that programming languages and databases really split into separate fields. And the idea of like the system that you use to wrangle your runtime in memory state and the system that you use to persist and query your persisted state are so separate in the way you think about them. Historically, you have systems like Smalltalk, for example, which have much less of a separation. They're closer to you have objects in your language and you're just saving those objects and reloading them. And there's much less of a gap there, right? And something I found interesting about some of the more recent work you've been doing in this space is, you've been working on tools that make it easier to close that gap and let you think about the kinds of in-memory objects that you want to be thinking about in your program, and turn those into the things that you want to be storing in your database and querying, and vice versa. And I think that's, again, one of the really interesting challenges in this space, is handling that impedance mismatch between a relational database and your TypeScript code or whatever. Do you want to talk a bit about that area you've been working on?
Yeah, totally. I think this is also like a for you like a broader umbrella of your work that contextualizes everything you've been doing over the past few years and will probably still be the foundation for the years to come is Malleable software. For me, common theme seems to be all around schema management and kind of fighting that impedance mismatch from different contexts. And so I've been trying to make that simpler in the context of Riffle, and in a way that nicely brings us back to the initial topic that we talked about with Cambria, since it's not just already hard to deal with that impedance mismatch between your application types that are expressed, for example, in TypeScript, and the way how a database thinks about it, how it stores the data. But both can also change over time. You want to implement new features, etc. So your database schema might change, your app types change. So you also got to deal with a schema change management here, which hopefully we'll get to bring some of the goodness of Cambria into the fold here as well. Schema migrations is still sort of a untamed problem, but we're getting ahead of ourselves here. So if someone in the audience thinks about, okay, Riffle sounds great, can I use it? You've been mentioning that you've been doing this as part of your PhD at MIT. What is the current state of Riffle?
Yeah, I get asked this question from time to time, so it's probably good to provide an update. So Riffle was a research project fundamentally. The goal was to explore this idea and see if it was possible or a good idea. Um, it ended up being part of my PhD thesis, and I wrapped up grad school. And at this point, sort of the core Riffle project itself is I would say it's basically over. We published a paper at the WIST HCI conference this year that summarizes some of what we learned. However, the ideas are not dead. So actually, you, Johannes, have been sort of carrying the torch forward of some of these ideas and building them into a new library that you're building, that has sort of replaced Riffle as the foundation for your work on Overtone. And so maybe you could talk a bit about your ongoing work there.
Yeah, totally. So for me, what's been the most valuable thing over the course of the past few years in terms of our collaboration is that collaboration, that partnership, and really doing a lot of research and exploratory work together. And then, yeah, B, having sort of like a prototype implementation of what that could look like. But it was really a prototype implementation that could prove out those different ideas. But to make actual progress with Overtone, I was running into a lot of the limitations of those prototypes, where it was working on the happy path. The not so happy path was unexplored, and it started causing a bunch of problems for me. So this caused me not to throw out the baby with the bathwater and reach back for something like MobX or Redux, but it has led me to, yeah, put on my dev tool builder hat again, and I started productionizing the ideas of Riffle more, and I did that under a new umbrella, which is a library called LiveStore. It is not yet open source. I'm hoping to get it open source sometime this year. Right now, if someone is curious to give it a try, it is possible right now if you are sponsoring the project. That's a topic for another day. I'm hoping to make the development of LiveStore sustainable, and through GitHub sponsorship is one way how I'm currently planning to do so. But yeah, the ideas of Riffle live on, possibly multiple projects in the future, LiveStore being one of them. I'm sure your work on Riffle has inspired more folks to implement similar ideas in the future. So that's what I can contribute right now.
Yeah, I'm really excited to see where your work with Livestore goes. I think you have some cool stuff cooking and places you're trying Livestore, and I'm sure you're going to keep learning a ton more about where this approach works and new challenges, right? But it's very exciting to me that these ideas are living on in your work.
Yeah. And so Geoffrey and I are still touching base every so often, and I share my updates and progress on LiveStore. And now, step by step, I get to make progress on some parts that we haven't quite got to yet while working on the Riffle research project, and where I get to unlock some progress where Geoffrey thinks, oh, yes, finally we're getting to that point that we haven't gotten to while working on Riffle. And I'm I have to face all of those bigger implications that we've been well aware of, but we just haven't gotten to them yet, whether it's schema migrations or making the technology actually local first. So introducing syncing and collaboration capabilities, and I want to do so in a way that is compatible with different kinds of syncing approaches, whether it might be something like Electric SQL or possibly something like AutoMerge or YJS in the future. So there, in a way, we've come really far, and in a way, we are just getting started. So I'm super excited about that. So we've been talking a lot about SQLite, Riffle, LiveStore. You've since moved on to new projects. So, and I think you're still at Ink and Switch, even more so than before. I think you're now full time at Ink and Switch and are already in new projects. So, which sort of problems are you currently looking at?
Yeah, so since finishing my PhD earlier, I guess last year over the summer, I've now for a few months been full time at the Ink and Switch Research Lab, where Peter Van Hardenberg again is the director. They're where a lot of they coined the term local first, right? And so they're what got me into this space in some sense, and I'm really excited to be full time there. I'm leading our Malleable software research track now. And so that's basically a research track where we explore these ideas around customizable software. And we really are interested, particularly in the intersection of the local first architecture and the malleable software agenda. And we have a lot of ideas for how those two things can be kind of complementary to each other, as I described earlier. We have some fun experiments brewing. One thing is that we're increasingly trying to use our own local first tools. So one little project I worked on in my past few months there is spinning up a writing tool that we use internally at the lab. We used it to write our last essay that we published, and that's based on the AutoMerge stack that the lab has developed. And it's a really nice way to sort of again just get some authentic experience using the stack and understanding the challenges and the good stuff, right? We're then kind of using that stack as a foundation to explore a lot more speculative stuff going forward. Some of the ideas we're excited to explore are the potential for version control in a local first environment. And if you have a layer like AutoMerge in your stack, which is really designed around not just local first data, but also storing past history of documents, what can you do with that potential to unlock for end users? And another theme we're going to explore and have started exploring a bit already is not just data in a local first way, but code in a local first way. So if you put code on people's devices in a way that they can mod themselves, what does that unlock in terms of customizing our software? This is sort of a fully maximalist local first approach. And it's something that Peter and the lab have explored in the past, but it's, there's a project called Pushpin, which I encourage people to look at if they haven't heard of it, which is basically an exploration of what happens if you have local first data plus flexible tools that can operate on that data. And I'm excited to keep pushing in those directions and see if we can basically give people more control and empowerment over their computing experience on top of this local first data stack.
That is incredible. I'm very tempted to also somehow contribute more in those various topics that you've been mentioning, but my day has just so many hours, and I think I have still a lot of work ahead of me with LiveStore and Overtone. However, I think there will be many problems that will have positive overlap. I think we're still not done with the Cambria problem. Maybe we get to collaborate there in the future. We've been doing also some really interesting exploratory work around what does it mean for an app to have version control for users. That is something I'm also really interested in. So I'm sure we'll get another stab at collaborating on some project together. But yeah, Geoffrey, I've been looking forward to this for a long time and really excited to share what we've been working on over the past few years with a broader audience. And thank you so much for taking the time and sharing all of those stories and insights with us. Thank you.
Yeah, thanks so much. It's been fun.
Thank you for listening to the Local First FM podcast. If you've enjoyed this episode and haven't done so already, please subscribe and leave a review wherever you're listening. Please also consider telling your friends about it if you think they could be interested in Local First. Thank you again to Expo and Crab Nebula for supporting this podcast. See you next time.